Hello students, how are you? I hope you all are fine and practicing maths. Now practicing mathematics doesn't mean that you have to solve questions all the time. Maths is everywhere. It is in your electricity bill, it is in the grocery list, and it is also in your father's bank account statement. But we need to learn new things in life. And the new thing that we are going to do today is Chapter 1 of Grade 8, Rational Numbers. Now what are rational numbers? Before telling you that, I need to tell you a short story. The story is about my student Raman. He told me that when he was very small, his mother gave him a few marbles and taught him how to count them. 1, 2, 3, 4. That day he was introduced to natural numbers that start from 1 and do not end. That is, they are infinite. One day his sister took all his marbles. His elder brother said, "Oh, you are left with 0 marbles?" That day he understood that when a number is subtracted from the same number, we get a number 0. When we add this number 0 to the set of natural numbers, we get a new set of numbers called whole numbers. Raman really enjoyed mathematics. One day he asked his teacher, "If we subtract 3 from 8, we get 5. But if we subtract 8 from 3, what will we get?" The teacher then told him the answer would be -5, which is a negative integer. This way he came to know that when negative numbers are clubbed with whole numbers, we get a set of numbers called integers. Once he was trying to solve a few equations. His classmate gave him an equation to solve. The equation was 2x plus 7 is equal to 0. That is, he had to find a value of x for which left hand side of the equation becomes equal to right hand side. After thinking for a while, he found that there is only one such number which satisfies the given equation, and that number is -7/2. But he was not able to understand that it was what kind of a number. Neither was it a natural number nor a whole number. It was not even an integer. Actually, such numbers are called rational numbers. That is, the numbers that can be written in the form of P upon Q, where P and Q are integers and Q is not equal to 0. Q cannot be 0 because division of any number by 0 is not defined. Children, just think whether 1, 2, 3, 4 and so on are rational numbers. And what about 0? Is 0 a rational number? So children, now we know that what are rational numbers. Let us play with these numbers. Take any 2 rational numbers of your choice. Hey Gillu, which rational numbers have you chosen? Oh, 1/2 and 3/5. So children, whatever rational numbers you took, first of all add them, now subtract them, multiply them, and lastly divide them. When Gillu did these operations, he got these answers. On addition, he got 11/10. On subtraction, -1/10. On multiplying, 3/10. And on dividing, 5/6. So have you got rational numbers as your answers, just like Gillu? And is it happening every time? Now take some more pairs of rational numbers and carry out the 4 operations. Oh, see what happened? Gillu took 2 rational numbers, 3 upon 4 and 0. Can we take 0? Of course, because it can be written as 0.1, so it is certainly a rational number. On adding these 2 numbers, he got 3 upon 4. On subtracting, 3 upon 4. On multiplying, 0. But on division, he faced a problem. Division by 0 is not possible. This means on dividing these 2 rational numbers, the answer is not a rational number. So what is the inference or result that we can derive from this? Rational numbers are closed under addition. Rational numbers are closed under subtraction. They are also closed under multiplication. But they are not closed under division. So children, just by playing with numbers, we have come to conclude about closure property of rational numbers. Now let us discuss the second property, that is commutative property. Take any 2 rational numbers, say 1 upon 2 and 1 upon 3. Let us add them. We got 5 upon 6. Hey Gillu, you have added it in the reverse manner, but the answer is same. This means 1 upon 2 plus 1 upon 3 is equal to 1 upon 3 plus 1 upon 2. Now take some more pairs of rational numbers. Add them and then add them in the reverse manner. Do you get the same answer every time? If yes, then we can generalize that for any 2 rational numbers a and b, a plus b is equal to b plus a. This is called commutativity of rational numbers under addition. Now we will discuss commutativity of rational numbers under subtraction. Take any 2 rational numbers, subtract them. Now subtract them in the reverse order. So according to your observations, are rational numbers commutative under subtraction? Now let us multiply 2 rational numbers. Minus 2 upon 3 into 4 upon 5. And let us now reverse their order. Now we will multiply 4 upon 5 with minus 2 upon 3. Is your answer same? But you need to try this with other pair of rational numbers to conclude that rational numbers are commutative under multiplication. That is, for any 2 rational numbers a and b, a into b is equal to b into a. Now let us take 2 rational numbers 1 upon 2 and 1 upon 3. 1 upon 2 divided by 1 upon 3 is equal to 1 upon 2 into 3 upon 1, that is 3 upon 2. And doing it in the reverse manner, 1 upon 3 divided by 1 upon 2 is equal to 2 upon 3. See, the answer is different. That is, rational numbers are not commutative under division. Let us tabulate our inferences. Rational numbers are commutative under addition. They are not commutative under subtraction. They are commutative under multiplication, and they are not commutative under division. Children, let us do a question. We have 3 rational numbers 2 upon 8, 3 upon 8 and 4 upon 8. Let us add them. I am not able to decide whether I should add 2 upon 8 and 3 upon 8 first, or 3 upon 8 and 4 upon 8 first. Let us try both ways. 2 upon 8 plus bracket 3 upon 8 plus 4 upon 8 bracket closed is equal to 2 upon 8 plus 7 upon 8, which is equal to 9 upon 8. Now let us do the other way. Bracket 2 upon 8 plus 3 upon 8 bracket closed plus 4 upon 8 is equal to 5 upon 8 plus 4 upon 8 is equal to 9 upon 8. Children, take some other 3 rational numbers and check. You will find that answer is same. We can generalize that for rational numbers a, b and c, a plus bracket b plus c bracket closed is equal to bracket a plus b bracket closed plus c. That is, rational numbers are associative under addition. This is also called associative property. Now let us check associativity of rational numbers under subtraction. Take 3 rational numbers. 5 upon 9 minus bracket 3 upon 9 minus 1 upon 9 bracket closed is equal to 5 upon 9 minus 2 upon 9 is equal to 3 upon 9. Now if we change the position of bracket, that is, we first subtract 3 upon 9 from 5 upon 9 and then subtract 1 upon 9. What do we get? We get 2 upon 9 minus 1 upon 9, which is equal to 1 upon 9. Which we can see that answer is different. So can we say that rational numbers are not associative under subtraction? Similarly, you can check associativity of rational numbers under multiplication and division and write your observations in a tabular form. Here I have already entered observations with respect to addition and subtraction. Rational numbers are associative with respect to addition and not associative with respect to subtraction. Now you will enter your observations for multiplication and division. I gave a question to my students and asked them to solve it. The question was 1 upon 7 into bracket 2 upon 5 plus 1 upon 5 bracket closed. Students solved it as 1 upon 7 into 3 upon 5, which is equal to 3 upon 35. But one of my students, Meena, solved the question in a different manner. 1 upon 7 into 2 upon 5 plus 1 upon 7 into 1 upon 5, which became equal to 2 upon 35 plus 1 upon 35. That is 3 upon 35. Children, answer is same. So we can say that 1 upon 7 into bracket 2 upon 5 plus 1 upon 5 bracket closed is equal to 1 upon 7 into 2 upon 5 plus 1 upon 7 into 1 upon 5. You can check this again by taking different sets of rational numbers. Hence we can conclude that multiplication is distributive over addition. Is multiplication distributive over subtraction also? Will 1 upon 7 bracket 2 upon 5 minus 1 upon 5 bracket closed equal to 1 upon 7 into 2 upon 5 minus 1 upon 7 into 1 upon 5? Children, do check it. Now let us tabulate these properties of rational numbers. This table shows whether rational numbers are closed, commutative or associative under addition, subtraction, multiplication and division. Now let us do a question using these properties of rational numbers. The question is, find the value of minus 2 upon 3 into 3 upon 5 plus 5 upon 2 minus 3 upon 5 into 1 upon 6. This is not a difficult question. You can simply multiply minus 2 upon 3 with 3 upon 5. Similarly, minus 3 upon 5 with 1 upon 6. You get 3 rational numbers and solve them. But here we are going to use properties of rational numbers to solve the question. Let us see which properties are helpful in this case. We can clearly see first term and last term has something in common. The common number is 3 upon 5. So we will try to keep first and last terms together. For this, first and second terms need to swap their places. But is it possible? Yes, because we have already observed that rational numbers are commutative under addition. So we reverse the order of first and second terms. So let us take out the common factor of second and third term, that is 3 upon 5. So what are we left with in bracket? 2 upon 3 and 1 upon 6. On solving them we get 5 upon 6. On further solving we get 1 upon 2. And finally on subtracting we get 4 upon 2, which is equal to 2. So children, you can see that using properties of rational numbers, we can solve such questions quickly and easily. Children, you should practice similar questions like the one I am giving you. Solve 2 upon 5 into minus 3 upon 7, minus 1 upon 6 into 3 upon 2, plus 1 upon 14 into 2 upon 5, using suitable properties. Children, did you see mirror in the morning? What did you see? Yourself or somebody else? I'm sure you must have seen yourself in the mirror. So it may be the case with rational numbers also. They may be having a mirror which gives them an exact reflection even after addition. That is, the identity of the number is retained even after addition. How is it possible? We add something but nothing is added. Fascinating, isn't it? Yes, it's possible with 0. 0 is a number which when added to a rational number gives the same number. That is why 0 is called additive identity of rational numbers. For example, which number should be added to minus 2 upon 7 to give minus 2 upon 7? There is only one such number, and that is 0. Now let us reverse the order. 0 plus minus 2 upon 7. This is also equal to minus 2 upon 7. So we can say that for any rational number a plus 0 is equal to 0 plus a is equal to a. It seems as if 0 is a mirror which does not change identity of rational number. That is why 0 is called additive identity of rational numbers. Now we will find multiplicative identity. That is, a number which when multiplied to a rational number gives the same rational number. For example, a multiplied by which number will give a? Just think about it. Which is the number that multiplied with a gives a itself? Let us take another example. 3 upon 4 multiplied by a number gives 3 upon 4. Which number can we put in the blank? There can be only one such number, and that number is 1. That is why 1 is called multiplicative identity of rational numbers. Let us write in general form. For any rational number a multiplied by 1 is equal to a, which is equal to 1 multiplied by a. Let us do a question. Minus 2 upon 3 when added to a number gives 0. I have specially taken 0 here because 0 is additive identity of rational numbers. So what would be the answer? The answer would be plus 2 upon 3. So can we say that minus 2 upon 3 plus 2 upon 3 is equal to 0, or 2 upon 3 is additive inverse of minus 2 upon 3. Generally, a upon b is additive inverse of minus a upon b, and minus a upon b is additive inverse of a upon b. That is the same number but with an opposite sign. Similarly, let us do this question. 3 upon 4 multiplied by which number will give 1? Why are we taking 1? Because 1 is multiplicative identity of rational numbers. This blank can have only one number, and that number would be 4 upon 3. So 3 upon 4 into 4 upon 3 is equal to 1. Generally, we can say that if we have two non-zero rational numbers, a upon b and c upon d, such that a upon b into c upon d is equal to 1, then we can say that a upon b is multiplicative inverse or reciprocal of c upon d, and c upon d is multiplicative inverse of a upon b. Now let us do a question. What is additive identity and multiplicative identity of 5 upon 9? Your options are minus 9 upon 5 and 9 upon 5. Second option is minus 5 upon 9 and 9 upon 5. Third option is minus 5 upon 9 and 5 upon 9. And fourth option is 5 upon 9 and minus 5 upon 9. Think carefully. I will tell you the answer of this question at the end of video. Let me ask a question. Which natural number lies between 2 and 4? Isn't it easy? It is 3. Now tell me, how many natural numbers are there between 3 and 4? You must be thinking, what kind of a question is this? Certainly, there is no natural number between 3 and 4. If I ask, how many integers lie between minus 9 and minus 10? Think about it. Now let us take two rational numbers, say 4 upon 10 and 7 upon 10. It's very easy to note that 5 upon 10 and 6 upon 10 lie between 4 upon 10 and 7 upon 10. But if I write these given rational numbers as 40 upon 100 and 70 upon 100, can we do that? Children, certainly. Now tell me, how many rational numbers lie between 40 upon 100 and 70 upon 100? You can easily see that 41 upon 100, 42 upon 100, 43 upon 100 and so on 69 upon 100. There are 29 rational numbers between 40 upon 100 and 70 upon 100. Think about it. Earlier there were only two rational numbers between given rational numbers. Now there are 29 rational numbers between the same given rational numbers. Now what if I write them as 400 upon 1000 and 700 upon 1000? Now how many rational numbers lie between the given rational numbers? Just think about it. Can we say that there are infinite rational numbers between two given rational numbers? That is, we can find as many rational numbers as we want between two given rational numbers. Let us do a question. Find a rational number between 1 upon 3 and 1 upon 6. We want only one rational number between two given rational numbers. We have a method which helps us to find a rational number between two given rational numbers, and that method is called mean method, or it is also called the midpoint method. That is, we are going to find the midpoint between two given numbers. We will first add these two rational numbers and then divide the answer by 2. So we will get a point which is the midpoint between two given rational numbers. And we know that this rational numbers lies between two rational numbers. Children, in this chapter we have studied what are rational numbers, how to find rational numbers between given rational numbers, and what are the properties of rational numbers. So lastly, we will know how to represent rational numbers on a number line. For this, we will draw a number line. Children, you can see that the number line has many types of numbers on it. Natural numbers, whole numbers, as well as integers. But you didn't know that rational numbers are also lying on this number line. You just need to know how we can represent them. Let us take an example. The number 1 upon 2 is a proper fraction. so it lies between 0 and 1. We will divide the distance between 0 and 1 into two equal parts. The point just after 0 will be marked as 1/2.
Now let us take another example 2/3. To represent 2/3, we will divide distance between 0 and 1 into 3 equal parts. Why 3 equal parts? Because denominator of fraction 2/3 is 3.
The point just after 0 represents 1/3. Second point represents 2/3. Third represents 3/3, which is equal to 1. We wanted to find 2/3, which is 2 places to the right of 0. So point B represents 2/3. Now let us do another example. Represent 7/5 on a number line. 7/5 is bigger than 1 and smaller than 2. So we will mark the point between 1 and 2. Children, can you tell me that we will divide distance between 1 and 2 into how many parts? Yes, it is 5 parts. Because denominator of 7/5 is 5. So when we divide it into 5 parts, we see that 1 is equal to 5/5. The point to the right of 1 represents 6/5. Then next 7/5. Then 8/5, 9/5 and 10/5, which is same as 2. The point which represents 7/5 will be marked as C. So children, now there is an assignment for you. You will represent -3/4 on the number line yourself. Can you do it? Between which two integers -3/4 will lie? Children, let us practice a few questions. These are multiple choice questions. Question number 1. If A and B are two rational numbers, then A plus B upon 2 is a rational number such that A is smaller than A plus B upon 2 and A plus B upon 2 is smaller than B. I am giving you two options, true or false. So children, what would be the right answer? The right answer is true. Question number 2. Multiplying two rational numbers gives a dash number. You have 4 options. Your options are A. Rational, B. Irrational, C. Natural and D. Whole. So what would be the right answer? The right answer would be A. Rational, because multiplying two rational numbers gives a rational number. Question number 3. What is multiplicative inverse of 1/5? Your options are A. -5, B. 5, C. -1/5 and D. 0. So children, can you tell me the right answer? Yes, the answer is B. 5. Question number 4. What is additive inverse of 2/8? You have 4 options. A. -2/8, B. 2/8, C. 8/2 and D. 1. So what is the right answer, children? The right answer is A. -2/8. Question 5. What is the reciprocal of 0? You have 4 options. A. 0/1, B. -1/10, C. 1/0 and D. Not defined. So can you tell me what is the reciprocal of 0? Yes, it is not defined. Children, I gave a question earlier in this video and promised you that I will discuss it at the end of the video. The question was, what is additive identity and multiplicative identity of 5 upon 9? And your options were minus 9 upon 5 and 9 upon 5, minus 5 upon 9 and 9 upon 5. Third option was minus 5 upon 9 and 5 upon 9. And fourth option was 5 upon 9 and minus 5 upon 9. So, what is the answer, children? Yes, the answer is minus 5 upon 9 and 9 upon 5. So, children, this was our chapter 1, rational numbers. I hope you have understood it and you will practice it at home. Children, in this chapter, I mentioned that division by 0 is not possible. Did you ever think that why is it so? Why is division by 0 not possible? Can we form a table of 0? Can we divide 10 by 0? Think about these little questions. It will certainly tickle your mind. Till then, stay safe, stay healthy, and keep learning new things in life. Thank you.